Okay, there might be, I don't know if everyone's table has enough, but your new first is actually not in your notes. It's this little half sheet that's on your desk, and it's going to be a good practice for y'all to see if you remember all the steps for how to do a regression on your calculator, except you're doing an exponential regression because we are in our exponential unit, and you could possibly need to do this on any of, I'll stay somewhere, on one of your assessments coming up next week. So try that out, see if you remember how to make a table or a spreadsheet in your calculator and then run a regression, and then we'll check it. Okay, let's see what's here. Okay, Israel,
Here.
Felix, Edith, Eli, Dahlia, Stephanie, Diego, Jamie Lynn, Sandy, Brandon,
Here.
Brian, can't read. Juan Carlos, Martin, Nen, Kennedy, Giselle, Leo, Gustavo, Lirio, Tyler, Melanie, Lazaro, Jonathan, Messiah, Joanna, Kevin, Eham, Christina, Johnny, Luis, Deanthea, Brian. Okay. Who's the other Brian?
I'm sorry.
Two of the whole pile of hash sheets that I was.
Yeah, they're right there.
I knew they were somewhere really close. Yeah. I'm just protected. I'll grab a teammate so that Ryan can try the different. Make sure you know how to do a regression for the quiz. Okay, here's the Unit 3 review, so that you'll have it for your quizzes and tests next week.
Oh, no.
Okay, y'all, so we've got Friday, so we got raffle going on, just for some of my leftover Halloween candy, because it was raining on Wednesday, so we didn't have as many trick-or-treaters as we hoped. So sad, but maybe not need to give prizes for today, so that's kind of nice. And we got a small group. Everyone's sick or something.
I'll be sick like in 30 minutes.
But a lot of people didn't they just leave? Like people are here this morning. They've just been getting picked up.
Some people check themselves.
I'll be sick in like 10
They're like, I'm
It's the
18.
group.
I'll be getting picked up.
I'm out. Well, thank you for being here. I hope you have plans this weekend.
The parade starts in an hour.
What?
The parade starts soon.
Isn't it like an hour?
Yeah.
Starts the first shot.
Kind of.
It starts at 2.
Can we see it on next week?
We should live stream. We should like.
We won't even be
Yeah,
here.
bitch. Let's go.
You'll be gone. Right? By 2:30?
No. Oh.
We get out.
We will live stream.
We get
So
out
maybe
at
next
4.
teacher will. Huh?
We get out at 4.
No, out of my physical
I
classroom.
didn't get
Oh,
it.
yeah, let's just leave.
You'll be out of here. Okay, so let's take a look at regressions. It's like so weird because it was kind of like deja vu that happened when I last time someone was using their calculator as a phone. Okay, so if you put this in as a spreadsheet, some of y'all might run the regression on where it gives you the little graph of it. I like a lot of times to just run the regression in a calculator page so that then when I have things to calculate, like here it wants you to calculate for 21 days, you're already there. So I went ahead and ran my regression in the calculator page. If you don't remember how, you go to Menu, Statistics, Stat Calculations, and then you would choose what type of regression did they ask for. Exponential, which is one of the ones in the list. And so it'll give you your data for your exponential equation. If this was a free response and I would have asked like part A, what is the exponential equation for this regression? You would have said 11.671 times 1.336 to the power of x, because that's the equation, is a times b to the x. A, it tells you is this, b, it tells you is this. So first check right now and see if you got the same equation. If you got something different, then we can check maybe something went wrong in your table or something like that. But these are the numbers you should have gotten. If you got this, then we now want to find for 21 days. So if we're already in our calculator screen, can anyone remind me from last unit when we did this, what can I do to quickly plug in 21 and find the number of moths? Kennedy?
Type in F1 parentheses.
Yeah, right here you see mine, it was called F1. So I say F1 of, and it like goes bold because it tells you I know that function. F1 of 21, sorry. And it gives you 5,145.4 blah, 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 blah. So we would say D 5,145. Okay? Cool. So we could find regressions. This problem really didn't require anything from this unit other than the fact that it's referring to an exponential. But again, once we have it, I could ask all sorts of things about this. For example, we know this is an example of exponential growth or decay? Growth. So like you could start to then figure out the domain and range of things, right? There's a lot of things I could then ask you about this regression once you find it, okay? So the important part is you know how to do it in your calculator and then apply the skills from this unit. Okay, so you've got your problem set due on Monday. Today you're going to turn in your participation tracker to me so I can enter those in this weekend for A2. And then your quiz is on Monday, your second quiz. So this weekend as you're working on your problem set, you can use that as practice, and then the stuff we're learning today, there aren't any problems on your problem set, but any of the problems we don't get to, I'm going to try to give you a lot of the answers so you can write them down, and if you want to finish practicing others at home, you can. Okay? Alright, and then your unit exam will be next Thursday, so next week is pretty much assessments and reviewing. And then Friday we'll start unit 4.
Yay.
Okay, cool. Moving on. Solving exponential and logarithmic equations. Yesterday we did one of these. Today we're going to do the other. Which one did we do yesterday? And you can flip now to your notes. Oh yeah, and then P.S. Y'all got one of these with a review?
Yeah.
So you can be using this as you study this weekend too. Should have all your properties, all your graphs, all of that. Which one did we do yesterday? Yesterday we solved what type of equation, Ehong? The logarithmic. Yesterday we said if I have log base 2 of x plus 4, x plus 4 equals log base 2 of 10. If those are the same bases, I can say x plus 4 must equal 10 and solve, right? Okay, so today we're going to solve exponential equations. So if it looks like this, we did this earlier in the unit. Those are easy too because the base is the same, so same thing, you can set the exponents equal, right? However, today we're going to start for the first time. What happens if you have something that looks like this? where I can't write 3 with a base of 2. So how would I solve and get this x out of the exponent and like down out of the exponent? So today we're going to answer that question and see what we can come up with, okay? To do that, we're going to start by actually looking at someone else's work that's already solved instead of me just modeling the first problem. And you guys are going to see if you can figure out what to do. So I believe we are on page 24. And if you look at where it says lesson 9, explore, that's where we are right now. So, thinking about the beginning of the problem, notice this is kind of like the situation I just said, where there's no way for me to write 6 to match the base of an e, right? No way for me to do that. So, I'm stuck. So what I want you to do is turn and talk to your neighbors. There's not many of you, so you're going to have to kind of make sure you're talking to each other and seeing what you think. From this second line to the third line and on, I want you to look at their work and see if you can figure out what strategy they used that we could try to use today, okay? Go for it. First, talk through this one, okay? I'm going to give out tickets to people out here talking about, neighbors.
Yeah.
About what they did. What thing? More specific.
You know, last round,
What are they doing in this line right here? What's different about this line?
They put the
Ellen. They put Ellen on both sides. Why do you think they put Ellen? What happens there? Ellen is
natural
and so we just get the 4 minus 3x. Now the x is not stuck up on top of the 4, okay? Okay, very good. Maybe write that down. We write each other out. Good job. Woo! Andy, you got it?
So the first question you have to write.
Oh, okay, so it's
Step 1.
4 in the back, 3 in the front, 7, okay, yeah.
And we're back.
Alright, step 2.
Okay, last chance for stamps today. So let's get some new people that need some stamps. Now's your time to shine. What did you notice that they did to both sides, Christina?
They take the natural base of both sides so they could cancel e, and then they set the exponent equal to the natural base
Of 6 on the other side?
of
Yeah. Cool. So we've got the natural log. That's what we call this ln, is the natural log. And for those of you that are like, wait, what is that ln again? That is a log. It's a log base e. But since it's special, it gets its own little notation. We write it like this. So that's the same thing as log base e. So they took the log of both sides. Just like any equation, if you do something to one side, as long as you do the same thing to the other side, it'll keep it the same. So they took the natural log of both sides, which keeps it equivalent, because if you do that, then this ln and this e to what power is e? E to the first power is e, so we say those cancel, and all we're left with is just the exponent 4 minus 3x on that side, which is great, because now the x isn't stuck up on the roof in the exponent. Now the x is somewhere that we can solve, right? Does the ln cancel with this 6 over here? No, e to, that would be equal to like, maybe like 1 point something or 2 point something, 1 point something. ln of 6, someone do ln of 6 in their calculator. E to the what power is 6? 1 point something?
1.7.
Yeah, so close to 2, but 1 point something. So this over here is not going to cancel because e to the 1.7 something power is equal to 6. So think of this as just a number, even though it looks weird. It's some decimal that we're going to leave like that until we get to the end of the problem. Okay, then we can solve like normal. So even if this is a number, I can subtract 4 and then divide by -3 to solve for x. And if this was a non-calc, you could just leave it as this expression, because we couldn't solve ln of 6. I wouldn't expect you to know that. If it was a calculator problem, then you just plug that into your calculator, and you would get 0.74. Now this is an example from, I think, a textbook, and they wrote it as 0.74. Can someone raise their hand and remind me how many decimals we would have to go? because we wouldn't get full credit with that. Lazaro? We have to go 3, and so be careful with that we're using their example, but we would need 3 decimal places there, okay? Okay, let's look at 3 more slightly different cases, and then y'all are going to practice 4 of these then with your neighbor, so let's take a look. First one, very similar. We've got a base to a power equal to a number, and I need to find that power that's stuck up top. Can I write matching bases in this case? No, this isn't like the examples we did that were nice and friendly. So we're going to have to do what to both sides? What's our strategy? Israel, what's our strategy for today? What does this person do to both sides?
So they wrote the equation, right? And then something with natural log.
The natural log. They took the natural log of both sides. So we're going to take the natural log of both sides of this equation. Because as long as I do it to both, it's going to stay equal. It's going to stay like an equation like this, okay? Once I do this, notice in this case, though, it wasn't E. And so, will ln and 8 cancel? No. So, side note for some of y'all that feel like you might be able to like push your thinking. You could always try, you could do whatever log you want. You could have done log base 8 on both sides, okay? But I'm going to kind of try to, I think it's going to help us, I noticed last year, to just use the natural log every time because you actually can just use another property of logs. What's another way that I can get this y, now that I have a log, out of like the exponent? Where can I put it, Lazaro? I can move it in front, right? And just say y times ln of 8 equals ln of 0.165. And then solve for y. By, because this is multiplication, I can divide by ln of 8 and get y equals, and then plug this into my calculator and see what I get, and that will give me the same thing I would have gotten if any of you were thinking of doing the log base 8 on both sides. You'll get the same thing. And I believe you get, when you type in ln of 0.165 over ln of 8, negative 0.867. Okay? Okay. One more case I want to talk about before I release you to practice. In part B, we got to be careful because in all of the examples so far, we have had some base to an exponent, nothing else, right? Base to an exponent on that side, nothing else on that side, right? In this case, I have my base. What's my base? 1.43 to the exponent. But then I also have on that side a little plus 3.1. What you cannot do, watch me, but don't write it down. ln of 1.43 to the a plus 3.1 equals ln of 8.48. It's really tempting now. Y'all are like, natural log, and you like just plop them on there, and then people just move the a in front. When I take the natural log, I have to take the natural log of the entire side. And can I move this a in front if it's only on the 1.43? It would have to be on the entire thing, right? So that's not going to work. So we can't take the natural log yet. How can I move this little 3.1 out of the way so that I can take the natural log of both sides? So just one extra step, Dahlia. Just subtract it over to the other side. And I'll have 1.438 equals 5.38, I think. If you subtract 3.1 from the other side. And now you should be at a spot where this looks like this one and you're ready to take the natural log and so on. So ln of 1.43 to the power of a equals ln of 5.38. Luis, what can I do with this little a exponent now that I have a log? Move it in front using the power property. And last step, because I want a, I can divide by ln of 1.43 and plug it in and solve. Okay? Not that bad. So just before you start taking natural logs, move anything out of the way until you have just the base and the exponent, okay? And for that one, you should get 4.705. I see some people doing it in their calculator. Okay, I'm gonna let you do a quick check on C. Try C really quick and then we'll check it together. And then I'm gonna give you an extended amount of practice time where you're gonna solve a bunch of problems with your neighbors once we make sure we're good to go, okay? So try one more on your own, and then I'll give you time to work with your neighbors afterwards. Try one on your own. This one. The whole thing, yep, the whole exponent's gonna run like in parentheses like on the same one chunk. This is a base and an exponent, there's nothing else being multiplied and permanently added. And so what can we do to both sides to try to get this down? So we can't, in this case, we can't have the same base, just like all the other ones we've seen today. We can't make that into a divider. The only thing we're left to do is take the natural log of both sides. Okay. What happens with ln and e? Now you just let the t plus g. When you put this in a calculator, just be careful on a calculator section, because you're gonna write ln and it's gonna pull up a parenthesis. We don't want the -2 inside, right? The -2 is on inside the ln, so make sure you do ln of 12 and then you subtract to the 2. Okay, I see a lot of people that got it, so I'm gonna go ahead and put up the answer and see what you get, and I'll put the non-decimal version too so you can see. You should have had, when you do all the steps, ln of 12 minus 2 over 5. Notice when you type this into your calculator is going to pull up ln of in parentheses, and if you type 12 and you automatically keep typing 2 minus 2, it's going to put parentheses like this. Is your 2 inside of the ln?
No.
It was subtracted like after, so you need to make sure that the way you type it in is correct to get the 0.097. If you got 0.4 or something,
Oh, wow.
watch out on your calculator how you entered it, okay?
That's amazing.
It's amazing.
Parentheses matter.
Parentheses matter. They're very important. That's what we have. They wouldn't matter. If they didn't matter, we wouldn't have them.
Commas matter.
Okay, 4 problems here to practice with. I'm going to set the clock for 4 minutes, which means you might not get through all of them, but I'm going to keep pushing us forward to some other examples. So 4 minutes, try out a few more of these to see how you feel. Make sure if it's not a base and an exponent, if there's other things in the way, you have to move those before you take the natural log. Go. You can do it. You can do anything. Who do I owe? Louise? Oh my gosh, I gotta get tickets too. I'm so behind. Do you hear singing? Woo!
636. So what was the answer? 6.7.
Noise. Alright.
You just take the. Oh no, you just put the
I know, so you put a little star so you can find it. I'm gonna go off these two extra, because I know where to put my phone. So put a little thing, so it'll be like.
Almost every.
Yep. How you doing? Good? Okay, so this one, what do you notice is in the way? The 2 is in the way. We just want a base and an exponent. The e's the base, the 7x is exponent, so I want to get rid of the 2. It's being multiplied. I could just divide by 2 from the beginning. 8 equals 42. Now it just looks like a normal base, and now I can take the natural one, okay?
Oh, I can do that in my head. 14 divided by 2.
Good, good, very good.
Work on this.
So before you take the ln of this, on this one, you gotta get rid of the 2. Because remember we said, kind of like in this example with the 3.1, you only want the number of the exponent, nothing else in front or behind. So we only want the e and the 7x, we gotta get rid of the 2 first, before we can do anything with that one. So we divide by 2 first, before you start multiplying.
Ryan's like, I feel like having a bunch of age at all. I could have been a substitute cover.
Yeah, I could have been set the target.
I'm gonna set it to Harvard.
Oh, I did.
How long did it
because I used to think that
But I just told you. No. I know it would be. I mean, I guess you can try, but. It's a lot of like essays and you got paper applications.
I didn't solve it, I just put the last thing.
I didn't think I could.
Well, I got X equals 1 until 42 divided by 7.
I like it because I thought it was good. I like went to my class master and was like didn't tell anyone first.
Oh no.
We didn't rank, I was at a like little bitty tiny school and didn't rank, so I didn't apply. But no, I wasn't top 10 either. But top 10 at my school was 8 people, and I wasn't the top 8 people. There's 80 people in the group. Ready? I was at my intention. Fun fact, didn't know, you have an understanding? Okay. Okay, 1.860. If you want me to write the LN version, I'll write it in case you are on a non.
Wait, if we don't remember what we found it from,
If you, okay, yeah, wait, so what did you get, 1.5?
that's it. Yeah.
No, then that must be, did you get LN of 28 over LN of 6?
Wait, no, yeah, I got it right, I just didn't math.
Let me see.
Did I set that back?
8, 5, 6,
Oh.
oh, gotcha.
Well, that's a lot.
Do you want?
Wait. But you would want to round this one based off of the next one. What? Did I get it wrong?
No.
No, you got it right.
Type it in your calculator again, let me come
You
check it
got
with
it
you.
No. I wrote it wrong.
Okay, cool, that makes me feel better. Because I was like, wait, I don't think I rounded, yeah, okay. Okay, and then next we got 0.534, you should end up with ln of 42 divided by 7. Okay, Kennedy, question?
So does it matter if we truncate or round?
No. So you could here have written, that's why I was wondering, what was the decimal?
59.
59,
Like more letters, more numbers.
it should have been higher than 7 or something. So you could do 859 and just chop off the rest, or you can round it. And I've noticed a lot of y'all rounding, so I'm just starting to put my answers rounded. But this would also be accepted. But I need 3 decimal places, either truncated, which means chop off the rest of it, or round to the 3rd decimal place, okay? Okay, then for the next one, you've got to divide first by 2.5, then start taking your natural log. You should have gotten a negative 2.277. And then the last one, you've got 2 steps before you even start. You've got to add the 0.3. You've also got to divide by the 0.75. Then you can take your natural logs of both sides. And you should end up with 1.375. So again, if you didn't finish some of these and you notice they're not on your problem set for this weekend, but you think you want to practice some for your quiz on Monday, then write down those answers and you're welcome to finish any of those off over the weekend if you're looking for problems to study, okay? Alright, next up, we start to crank things up a notch, and you won't see a ton of examples like this, but you definitely will see equations that have exponents with x on both sides. So let's talk about how the algebra gets a little bit crazier with this, but still nothing that we can't handle. So we see this. We see a 4 and we see a 3. If it was a 4 and, for example, a 16 to the 2 minus x, remember the other week we learned we could write this 16 as what? 4 squared, and then just distribute the 2. And then say 3x minus 1 equals 4x minus 2x and solve normally. Okay. Now unfortunately here, there's no way for us to write the 4 as a base of 3 or a 3 as a base of 4. And so we're back to the strategy from today, which means what are we going to do to both sides? Take the natural log of both sides. But this time, the crazy part is that I end up with moving an exponent using the power property to the front, but for both sides, okay? So I end up with 3x minus 1 times ln of 4 equals 2 minus x times ln of 3, okay? When we get to this point, again, I want you to think about ln of 4, not as, I think because you see the 4, a lot of people think of that as like 4 or something with 4. ln of 4 is e to what power equals 4. So again, that's just some decimal 1 point something that now we have multiplied times 3x minus 1. If I have a number, let's say it's 2 times 3x minus 1, what would I do with this 2 to get it to multiply it times something that looks like this? I'd have to like distribute the 2 and say 6x minus 2, right?
Yeah.
Okay, so I'm going to distribute this ln of 4 to both of these pieces, but it's just going to look kind of funky because we've got an ln of 4 like hanging out. So we're going to have 3x times ln of 4 for this piece, right? Minus, what's 1 times ln of 4? Just ln of 4. 1 times anything is just the number itself, right? Do we see how I put the ln of 4 with both of those? Okay. On to the other side. ln of 3 times 2. I have 2 writing this down. Follow with me, because if not, if you just copy it down later, you're like, where did all those things come from? 2 times ln of 3 minus x times ln of 3, right? I'm just multiplying ln of 3 times all of the pieces. Okay, the goal is to solve for x, which means we want to put the x's together. So I see an x over here attached to all this stuff, but there's an x. Where's the other one? On the other side, which means let's move this to this side. So if I want to move this, instead of saying minus ln of x ln of 3, I would add x ln of 3, right? To the other side?
Yes.
Yeah. So I'm going to add 3x ln of 4 plus x ln of 3, right? I just added this over here. Okay. This ln of 4, does it have an x in it? So I'm actually going to move that to the other side. Okay, I'm going to do 2 steps at once. because if it doesn't have an x, I'm going to kick it out to the other side. So if it's minus ln of 4, how do I get it to the other side? Plus ln of 4 means I'm going to have 2 ln of 3 plus my ln of 4 from over there. So notice, I'll kind of color code a little bit better. This thing and this thing had my x's, so now I have both of them on the left, right? And then this thing, the ln of 4 and the 2 ln of 3, they both did not have x's, so I moved them, they're both now on the right side. Okay? Cool. So I'm just trying to get my x's together. It looks different because I got ln splitting around, but this is the same thing you would do if you had normal like x's in a normal equation. Okay, the only thing that's different is it's hard for me to add these together unless I know what this number is equal to, right? If I have 2x plus x, y'all say, oh, that's 3x, right? In this case, I can't really say ln of 4, 3 plus ln of 3, like that's weird. And so one way to think about this is if both of these have an x, what can I do with that x? I can, Dahlia, like factor out the x out front and write this term would have 3 ln of 4 left behind, right? And this term would have just the ln of 3. So you can put the x back in with each of them. You notice this, I've got 3 ln of 4. The x is out front. This, the x is out front, so I just have ln of 3, right? Equals 2 ln 3 plus ln of 4. Okay, last step. I'm really close to having x by itself, but right now it's multiplied times this big, long expression. If it's being multiplied, the only way to get all this to go away is to divide by this whole madness. And that means I'm dividing over here by 3 ln of 4 plus ln of 3. And then you're ready to just plug this. You've got x on this side, so you just plug this whole thing into your calculator. Or if it's non-calc, you leave it like that. But if it's calculator, you can plug in 2 times ln of 3 plus ln of 4 divided by 3 ln of 4 plus ln of 3. And then you're like, wow, look at all that math I just did. I'm wonderful. That's what you have to say after.
You're wonderful.
You're wonderful.
Let's go on here.
Okay. 0.682?
Yeah.
682?
Yep.
Okay, so let's try at least one of these, and then we're going to move into the land of word problems to make sure you feel okay when I put this into a context of a problem. So if you, these are the last two, we're not going to do the extension down on the bottom unless you finish early and you really want to try it. I kind of left it on there because I had extra space for the paper. So if you want to look at the extension, you can. But I want you to practice one or both of these. And then in our last 5 to 7 minutes, we're going to look at a quick word problem or two, okay? I'm going to give you 3 minutes. Go. Try it out. You got 3 minutes. Go, go, go. Take the ln of both sides. What do we got in front? How many of these? Oh, wow, brother.
I'm serious.
That magic stuff.
Good job. Good job. Good job. Who are you?
That's you.
You want to.
Twice the chance.
Sorry, okay.
Actually not good. He'll probably go win.
It says something about the people that back.
Only thing here, it says it's in parentheses, so you have to multiply that one as 6 times both. So you need another little element here, with 3.
Your y is always a price.
And then here, you need parentheses, which means you've got,
Mom, get here already?
yeah. Good, now you're looking for the x's. This is an x,
Everybody went home, man.
and this is an x. So you're gonna add this x on over here. Drag this thing Good.
I did.
Good. So now move this x over here to be next to this guy that has x, and move this non-x to the other side. Okay?
This is raffle, right?
This x over here, non-x over the other side.
Oh, okay.
I'll give you a few more seconds on this because I know this takes a while to solve. Signature over here. Okay, so what today key idea is what are we doing both sides? Take the natural log of both sides. And the reason we do that is because then we have the property that says the exponent.
Oh, that's what the board.
So right here you do this whole thing from here.
Yep,
You do this, and then you put this up there.
yep,
Okay.
Step in here,
yep.
then after that,
And then after that, you gotta distribute the zone of 6 to both of these because you're multiplying them.
so
After we move the terms, we take out.
Yep, so now you have to multiply ln of 5 times both of those, and ln 6 times both of those. Okay, y'all, I want to keep us moving because I do want to get to a couple of the examples of word problems you could see, and then you won't, I don't think you'll see any of these anyways on your quiz on Monday, and we'll review them more on Wednesday before we get to like the unit exam and stuff. So if you didn't get to both of them, that's okay. We should have ended up with, and it's hard if you got a different decimal to know kind of where along the way you could have gone wrong, but you take the ln of both sides, move the exponent in front, distribute, move your like terms together, pull out an x and divide, and I believe we should get negative 1.070 if you want to finish it off and check your work later, or if you already got an answer, check and see if you got that, and I can look at your work in a second if you missed something, okay? Do you guys something different?
Yeah.
Okay, let me come look, okay? Okay, and then if you want to work on this one later, I didn't see many people that got there, but if you want to write down that answer and use that as practice this weekend, there's that one, okay? Okay, what we're going to do is turn our attention now actually to the back of your do first. I picked 2 problems since there weren't any word problems in your notes that were... Oh, you need another little half sheet? You didn't have the regression problem at the beginning? I'll get you one. Can I get someone to read this first one for us? And we'll get it set up together. And then hopefully have time for both of them. We'll see if we have time. Can I get someone to read for us the first one? Oh, you got one? Thank you. Go for it, Messiah.
It says you buy a new computer for $2,100 and the computer decreases by 20% annually. The value of the computer can be modified with the function of n equals n 0 that. And then how many years computer have and how many years computer has a value of 600 rounds in years.
Okay. So this is similar to problems we solved before where you have like a starting value and a rate and a time. And you either have one of those 2 equations, right? They actually give you which equation we're going to be using here. We're going to be using this equation. Y'all remember you memorized this for the quiz earlier this week?
Yep.
And this, we're using it because the percent is an annual fixed interval that it's being applied at, okay? Okay, so using that, let's plug in what we know. Raise your hand if you can tell me something that we know that I can plug into my equation. Kennedy?
You have to set the equation equal to 600.
Yeah, in this case, we actually aren't solving for our new value. It tells you that the value is going to decrease to 600, and so that's actually our answer, which is why this is going to be a solving example that we're going to do, okay? Do we know the, and not the original amount that the computer was worth?
Yes.
Cool, 2,100 times 1 plus, do we know our rate? Okay, and that is, Lazaro, what? 0.2 or 20%, and if it's decreasing, actually, maybe I shouldn't have written plus, I should have written a minus 0.2 raised to the t. So this time we are solving for the exponent, which you'll see a lot because that combines this skill, this equation, with now what we did today, solving how do we get that t, like out of the exponent. We learned how to do that today, okay. Before we start, I can actually just do what is 1 minus 0.2, so I can figure out what the base is. What's 1 minus 0.2? Okay, 0.8. So 2,100 times 0.8 to the t. Okay, on this side, do I have a base and an exponent, or do I have a base and exponent and something else? I've got a base of 0.8. I've got an exponent and a t. Is that all I have, or do I have something else? What else do I have on that side? Luis? Getting those participation points. He's got 2,100. We gotta get rid of that before we start doing our natural log, right? So I'm gonna start by dividing 2,100 on both sides. And you'll end up, I think, getting 2/7 if you put that in your calculator. It'll simplify it for you. Okay. Now, Brian, over to you. Once I have something that looks like that, if my bases don't match, what can I do to both sides to keep solving? What did we learn today?
You put ln.
Then take the natural log of 2/7 and take the natural log of the 0.8 to the power of t. Okay? Stephanie, what happens to that t after I do that? Goes in front. ln of 2/7 equals t times ln of 0.8. D'Anthony, take it away. By what? ln 0.08. And then a 0.8. And t equals, when you plug that into your calculator, 5.614. Which means rounding to the nearest number of years is what it says. So this, don't go through decimal places because they told you specifically, you wouldn't really ever say 5.61 years, right? We would say a year amount. So they're going to say 6 years if you round that to the closest year. Okay? All right, so using that, you've got 2 minutes left. So I want you to at least set up, every person here, 100% of you, I want you with this in front of you. The next one, I want you to at least fill in the information you have. You probably won't have time to finish solving, but I want you to at least set it up. And I'm going to leave you with the answer so that you can finish it off this weekend and have it. While you are doing that, I'm going to raffle off our winners while you're setting up your equation.
Maybe.
Okay, here we go. 462,264.
That's me, that's me.
That's you?
Wait, no, it's 244?
264.
Oh.
264?
243.
No? Okay, no one. Try again. Go, 264 is you? Good job. 261. Up, Louise. 263.
You pick it in. Oh, why that too?
And
244.
a new one. 237.
Hey!
Alright,
Oh, that's
come on
right.
now, get some candy. Everyone else, leave your participation trackers in a pile. And here is your final answer for the second one if you want to write it down. Here, it's back. Where'd it go? Oh, on that chair, that right has some candy.
No, I take it back and take the second.
Yes, let me go stand. How many did you have? How many did you have? 2? 4?
You know what?
I only won once. You pick one of my
Yeah, leave them on your table. Leave them in a pile at your table. Wait, what do you want?
I'm sure, alright.
No, this is so sweet.
Luis, I owe you one, right?
No. I got like 20 chickens. It's Swedish. LA Fitness, bro. Joe, wine. Oh my god, wine, please. Come on.
Alright, take your study guide. Study for your
Jackie.
quiz.
And wine. Not and wine.
No.
Right? He's been having software friends.
Great. Show up.
He's trying to name them all. He only named two. Me and Kelly.
Wait, what was the answer?
The whole group was in there.
29 days, 28.88.
Oh yeah, Hector.
Hey, you forgot.
Oh,
Thank you.
You do, huh? That's your
Oh, Keith. Keith, I just locked it.
I'm gonna watch Keith
Are you
No,
serious?
no, no,
That's
it's not.
Kelly. Keith is Kelly.
Okay, that.
Mr.